Assalamualaikum and a very good day to everyone. My name is Hazim Putra and today I will present my final year project entitled Design and Structural Analysis of Skilled Landing Gear. My supervisor name is Dr. Nizam bin Dahalan. Okay, basically helicopter are using two type of landing gear, which is wheel landing gear and skid landing gear. So there are many pro and con of the wheel landing gear and skid landing gear. For example, wheel landing gear easier to taxi compared to skid landing gear that need to use external force or use platform dolly in order to taxi. However, wheel landing gear has high maintenance cost and heavier compared to the skid landing gear. However, for the retractable wheel landing gear, it produce lower drag. Okay, the next one is the literature review. The first one is structural and drop test analysis of helicopter landing skid by D. Anita et al. This journal was released in 2017. In this journal, they are using Fury helicopter. We can see in the slide is the design of the Fury helicopter. Okay, this is the drop test setup in the ANSYS software, and then tables show the data for the drop test. And then the material used for this analysis is steel, aluminium, and titanium. So we found that the most lowest weight by using the same geometry is aluminium 7075T6. So from this we get the result for the maximum deflection for the static and for the maximum analysis for the drop test. We found that the result for the all is almost the same. So we decide that the most suitable material to use is aluminium 7075T6 because it's produce the lowest weight. Okay, the next literature review is Design and Structural Analysis of Skid Landing Gear by S. Naresh Kumar et al. This journal was released in 2014. So basically in figure 3 we can see the design of this skid landing gear. So they are using aluminium, titanium, and alloy steel. So it found out that the density of aluminium 7075T6 is the most lowest. So by having the same geometry, it means that aluminium 7075T6 is the most lightest compared to other. So as you can see in figure 4, figure 5, and figure 6 is the result of the analysis for the that been used in that been made in ANSYS for the aluminium, titanium, and alloy steel. So we can see that the most critical part is at the center of the cross part for all of the material. So from the maximum deflection result, we can see that all of the material is almost the same. However, for the maximum stress, we found that the aluminium 7075T6 is the most lowest maximum stress compared to the other. So aluminium 7075T6 is the best material to use. Okay, the next part is problem statement. So after doing many literature review and research, I found out that there are rare data analysis on skid landing gear, especially in Malaysia. Also, by changing from the wheel landing gear to the skid landing gear, it will decrease the maintenance cost and decrease the empty weight, which can increase the payload. So in this research objective is to design the structure of skid landing gear of helicopter with analytical and numerical solution. So for the scope for this research is first a literature review of the skid landing gear of the helicopter, and then determine the initial dimension and geometry layout for skid landing gear for alert 3, design the skid landing gear, design the attachment for skid landing gear, analyze the critical stress using theoretical method, analyze stress and deflection for the landing skid using numerical method, and then we do the result and discussion. So this is my Gantt chart for the semester 1, and then this is the Gantt chart for the semester 2. Okay, the next is flow chart of this project. First, we start with doing some literature review, and then select the helicopter, and then do the conceptual design, and then determine the load, and then select the material. After that, we do the analysis design, and then we do the analysis of the design into analytical and finite element method, and then after we get the result, we compare the result. Okay, for the helicopter selection, I have select alert 3 to do to design the skid of this alert 3. The reason why I choose it because currently alert 3 is using by Royal Air Military of Malaysia, and it's using the wheel landing gear. So I try to design the skid landing gear for this helicopter. Okay, in figure 7 show the helicopter configuration, and then you can see that it has maximum mass of 2200 kilogram, and after doing the literature review, it found that the most suitable material to use is aluminium alloy 7075T6, which have yield strength of 572 MPa. Okay, for the load determination, it found that to find the weight that we use in the calculation, we must we must first refer to FAR 27, which I have referred, and then it found out that the safety factor that we use is 1.5 and the load factor that we use is 3.5. So in order to find the weight, mass times gravity times safety factor times load factor, so we get the maximum gross weight that we use in the calculation, which is 113,304 Newton. Okay, basically these are the preliminary design of the skid landing gear, and then we can see that it consists of 3 main parts, which is fuselage attachment, cross part, and skid part. Okay, the next one is to do the dimension estimation. Okay, first to do the dimension estimation, we are doing the parametric studies, which is we get the dimension of A, dimension of B, and C. A is the length from the cross part to the cross part, and then B is the maximum width, and then C is the maximum length of this skid. So after doing some research, the data that I have I can get. So by having this data, I will I'll generate the graph, and then so we can estimate what is the dimension of A, dimension of B, dimension of C by using the maximum take of weight. And then the next part is for fuselage attachment diameter. For fuselage attachment diameter, it's only involve normal stress. So by using formula normal stress, we found that the minimum diameter that we use is 7.94 mm, and the proposed diameter is 20 mm. So for the cross part and the skid part diameter, it involves normal stress and bending stress. As you can see in figure 10, at point A and point B is the most critical point because it involves bending moment and normal stress. So to find the in A and B, we need to find MA and RA. To find the MA and RA, we just use the statically indeterminate method, which using the delta B1 equation and delta B2 equation, and then we can get the MA and RA. So after that, by using the bending stress formula and normal stress formula, we can find the minimum diameter that we can use for the cross part and skid part diameter. By using the outer diameter at 80 mm, we found that maximum inner diameter by using normal stress calculation is 79.6 mm, while for bending stress is 69.7 mm. So our proposed diameter is 60 mm. So in figure 11 show the design of cross part, and then figure 12 show the design of the skid part, and then 13 is a design of fuselage attachment, 14 is design of skid attachment between cross part and skid part, and then figure 15 show the design attachment between fuselage attachment and skid part. Okay, this is our full assembly after we have designed the every part. Okay, the next one is theoretical analysis. So by using the bending stress formula and normal stress formula, we found that normal stress is 12.281 MPa and bending stress is 352.404 MPa. So by have that value, we can do a diagram for the calculation, and then we get the von Mises stress, which is 346.426 MPa. Okay, for the simulation analysis, we start with import the geometry, and then we choose the material, and then we do the meshing, we choose the bonding condition, we choose the loading condition, and then we may analyze, and then we get the result. Okay, for the geometry, because of limitation of computational, and my computer is not high spec, so I can only analyze quarter part of the skid landing gear. However, it still can be accurate because my skid is symmetry to the 4 part. So in figure 20 show the design of quarter part of the skid landing gear. And then in figure 19 show the design mesh in NCs. Then in figure 21 show the load applied on the skid landing gear. So we can see that the force is divided by 4, which is we get 283 to 6 Newton. And then for the bonding condition, as the bottom part is the fix, so we set it as a fix. And then for the part that we cut into 4, as such as part 2 and part 3 in figure 22, is we met also as a fixed point. Okay, the next part is mesh conversion. Okay, in the ANSYS, we can do the mesh conversion by simply add the command of conversion, as you can see in figure 23. So after we get after you do the conversion, we get the result, which is for the displacement and stress. So for the figure 24, show the graph of displacement versus number of nodes. And then 25, graph of maximum displacement versus number of element. And then figure 26, graph of maximum stress versus number of nodes. And then figure 27 is graph of maximum stress versus number of element. So we can see that it's almost constant. Even it's not constant, it's almost constant. So our mesh conversion is complete. Okay, for the result of the stress, we can see in figure 28 and 39 is the result of the stress. We can see that the maximum stress is 417.18 megapascal. And then figure 30, 31 and 32 also, we can see the stress result. You can see that the maximum stress is at the fuselage attachment. So for the displacement, we can see the result as in figure 33 and 34. You can see the figure. We can see also the result in a figure in the screen, which is the maximum is in at the fuselage attachment, which is 0.0014556 meter. So the next one is to find the margin safety and the error of this simulation. So from theoretical calculation, we found that the maximum stress is 346.426 megapascal. And then we get the margin of safety of 0.6511. And for simulation, is maximum stress is 417.18 megapascal, which have the margin of safety of 0.3711. So from the result, we can get the percentage error, which is we get this percentage error of 17%. So even though the 17% is not good enough, because we need under 10% to be a good result. However, it's still acceptable because it's around the 20%. Okay, in the conclusion, the structure and integrity of the skid landing gear model is tested and validated using finite element analysis. The maximum stress for the theoretical and software analysis is 346.426 megapascal and 417.18 megapascal respectively. The error of the simulation is just 17%, which is acceptable since it's around 20%. However, because this error might be due to the computational restriction that the conversion cannot go to until 0%. However, it still can be accepted because it's around 30%. So also design for skid landing gear for alert 3 satisfy the requirement of static analysis, and it require the analysis in dynamic condition for the next detailed design. By designing skid landing gear for the alert 3 is good for the development of the helicopter, as it provide a lighter empty weight and lower maintenance cost. Also, by using civil standard, which is FAR 27, the skid has been designed for the alert 3 in this project still can be used for alert 3 if it's converted to be used in the civil helicopter. So the recommendation for the next project is use higher spec of the computer in doing the analysis, as it hinder the limitation of analysis. And then apart from the static load, dynamic load should also be considered in the next design. And then drop test of the skid should be performed to ensure the safety of the skid landing gear. And then consider to use composite material as it offer lower weight but higher strength. Okay, that's all from me. Thank you.